Hey kids! All right, get ready for some fun stuff today. This is lesson 11 in module 3 and it is a fun one. It's a weird one. You're going to learn some new stuff and we have some new words at the beginning that I will probably not use that much, but these are the official words. I just don't use them that much. Lesson 11 is about subtracting fractions while making like units, and you might say, hooray, we've already done that and we know how to do it. And I'll say, yes, but we have 3 methods that you can use. So I want to introduce these and make sure you understand what you're doing when you subtract. So when you subtract, I keep talking about the whole. The whole is also known as the minuend. We're going to minus something from the minuend. I almost could never remember them. The minuend has an M in the beginning that comes before S. The subtrahend is the part that we're taking away. If that helps you remember them, then good, good. When you get the difference, that's the answer to your subtraction problem. I use this word whole a lot in place of minuend because I want you to think about that you are taking away from the whole. So the problems we've been doing have been very simple so far, like 1/3 minus 1/5. Okay, we need a common denominator. You get that and you do your subtraction and it works out great. And this one is just the London's way, or the tall way, the old-fashioned way that I used to do it, and that was having the equivalent fractions here and then doing the subtraction going like that. And again, whatever makes you comfortable. So let's check out this lesson. What are these 3 methods that I'm talking about? So we've been doing the new way, and that's right here. Method 1 is to take this problem 1 3/4 minus 3/5 and to recognize that 1 in itself can be any fraction you want over whatever number you need. So if I need to take away 3/5 and I don't even want to bother with this one, turn 1 into 5/5, do the subtraction. 5/5 minus 3/5 gives you 2/5. Now that I have taken away the entire subtrahend that I was supposed to, I just put back the parts. This is what's left over with what I never even touched. Now I have this part here that I have to have a common denominator for an addition problem. But when you find the common denominator of 20 and you make equivalent fractions, then you end up with 23/20, and you would straighten that out, this improper fraction, to be 1 3/20. This is one way of solving. Sometimes it kind of takes a little bit of extra work and you say, oh, I don't really want to do it that way. That's fine, because there's another way. This one happens to be pretty short and simple this time. And so for this one, because when you make a common denominator for the 4ths and the 5ths, you end up with a big enough number here to pull from here. Then you just don't even have to bother with this one. And so really the subtraction problem is happening here. So you do your subtraction, and this is what's left. Nobody ever touches the 1, it just keeps coming down. 1 is part of the minuend, the whole, and we never even have enough to take away from it. So that's method 2. So you can always just look at the size of your fractions and use that. Now for method 3, this is how I used to do it and how your parents probably know how to do it. And this is to take this first number, the minuend, and to create this whole improper fraction. So it's all wrapped up together. So I've done this thousands of times where you just take your denominator, multiply it by the whole, add this, so that you know if I had 4/4 here, 4/4 plus 3/4 would make 7/4. But a quick way, how I would do it, how your parents will do it, is 4 times 1 is 4 plus 3 is 7. So you wrap this minuend all up together in a fraction, not having a whole or multiple parts. You just put the entire thing together. Then get a common denominator and calculate by subtracting from here. When you end up with your improper fraction, straighten it out into a mixed number. These are the three methods of subtracting with fractions. And you can use any method you want. I think in the book I probably am going to go back and forth, just kind of whatever's easiest. And sometimes I'll start one way and it won't be the easiest way, and then I'll be like, oh, that took a lot of work, but it is what it is. Now here's another sample problem. Okay, this is the minuend, again, the whole. And so for this one, it's like, let's try this. 3 minus 2, let's just take away the whole. Now leave it alone. Bring down the 3/5 and take away 1/2. You do have to think about this. Is this fraction going to be big enough to take away this fraction? I think when we first start out it will be, but then later on you'll have to figure out how to regroup with this one. So for right now, 3/5 is big enough. You change it so that you have a common denominator and then do the subtraction. Okay? This is the old way, where if you want to turn this into an improper fraction, you will definitely have a big enough number up here. You just have to have a common denominator. And oftentimes, these numbers here will be quite large. And sometimes your denominator will be quite large, and then you'll have to do some calculating off to the side. So if you choose to do it this way, 5 times 3 is 15, plus 3 is 18, 18/5. And then again, change this to a fraction as well. 2 times 2 is 4, plus 1 is 5, 5/2. So now you just have a fraction subtraction problem. Get 10 for the common denominator. Use the scale factor. If 5 times 2 is 10, then 2 times 18 is how you get your new numerator. If 5 is the scale factor for this one, 2 times 5 is 10, but 5 times 5 will give you 25. Do your subtraction, straighten it out. And then for this one, if you use the, you've got your 3 3/5, and let's just ignore this for a minute. Do 3 minus 2.5. Okay, so just, it's hard, but you just ignore that part. What's 3 minus 2.5? Well, 3 minus 2 is 1. 1 minus 1/2 is 1/2. So you're left with 1/2. The answer to this part is 1/2. Now put that back with what you never touched. This is that new way here that might throw you off a bit. And so then it turns this into an addition problem, but you still have to have common denominators. Once you get the common denominators, you can add and then straighten it out into a mixed number. So crazy stuff in subtraction today. And while I clean up my little cards, we will get into our book. So pull out that Learn book and your lesson 11 problem set, and we'll get to it. Move all my things out of the way. You don't need to use a fraction model, and you don't need to use a number line except for this last problem down here on H where it says to draw a number line. So it says generate equivalent fractions to get like units. So when you are not sure what the common denominator is, that's when you're going to line them up and skip count. I hope you know that 2 times 3 is 6, and so we can have 6ths minus 6ths and use each opposite as the scale factor. So 3 times 1 gives you 3. 3/6 is equal to 1/2. 2 is the scale factor, so 2 times 1 is 2. And then you have 3/6 minus 2/6 is 1/6. That's a mouthful. All the THS, very hard. So 7/10 minus 1/3. So again, getting a common denominator. Between 3 and 10, the only way I can have anything common is by multiplying. So we'll have 30ths. So 10 times 3 is 30. So to get this number, it's 3 times 7 for 21. And to get 30 over here, it's 3 times 10. So 10 times 1 is 10. And 21 minus 10 is 11. So nothing fancy yet because we haven't had any mixed numbers. It's really just warming up with our basic subtraction. Now on C, the best common denominator is the lowest common denominator. I don't want to multiply and have 32 be my common denominator. I don't even want to use 16. Why would I want to change anything if I didn't have to? Notice that 8 is a multiple of 4. So the only one that needs to be changed is the 3/4. And I can get from 4 to 8 by multiplying by 2. 2 is the scale factor, therefore 3 times 2 is 6. Once you create this simple equivalent fraction for this one, you can do your subtraction and you have an easy answer. The best common denominator is going to be the lowest common denominator. Now, finally, we have something that we can work with. If you want to do the new way, you can use 8/8 in place of 1. Subtract the 3/8 and get 5/8. Now, I have taken away all of this. It's removed. So what do I do with this that's left? I have to put back the 2/5 that I never touched. So this is where you need to have a common denominator. And I can use 40. And so from 8 to 40, this would be with a scale factor of 5. 5 times 5 is 25. To get from 5 to 40, it's a scale factor of 8. 8 times 2 is 16. Excuse me. I feel like it's a long day. 25 plus 16, 41 40ths. And that would make 1 and 1/40 because 40 goes into 41 one whole time with 1 left over. Now this is one of the ways. You don't have to do it this way. You could change this to be 7/5 minus 3/8 by doing 5 times 1 is 5 plus 2 is 7, and then subtract that. And again, you would have 40ths. Okay, and then you would do your subtraction that way. This one would give you 8 as a scale factor. It would be 56 40ths minus, and then 5 is a scale factor, so 15 40ths. And then you would get the 41 40ths here. So this is just another way. And I don't really want to take the time to do them all 3 ways. I just want to show you a couple for each one. And of course, you would end up with 1 and 1/40 for that answer as well. Okay? 1 3/10 minus 1/6. Again, if you wanted to use 6/6, you could do that and then subtract the 1, and then you still have to have a common denominator. You could wrap this up all into 1. 10 times 1 is 10 plus 3 is 13, so have 13/10. Or you can, what's that middle method? So there's so many different methods. Let's try the new way one more time, and then maybe I'll do the old way only on this next one. So the new way is to use 6/6 right here minus 1/6, and that gives you 5/6. So I took this and I subtracted everything. That leaves me with 5/6. But for this 3/10, I still have to consider that I had that in the beginning, so I will add that to my, I will add that to my 5/6. So many options. And so then the lowest common denominator between 10 and 6 is not 60, it's 30. So we're going to go over here and have 30ths. And to get from 10 to 30, it's a scale factor of 3. 3 times 3 is 9. To get from 6 to 30, it's a scale factor of 5. So 5 times 5 is 25. 25 plus 9 would be to go up 10, 35, and down 1, 34. 30ths, and then we're getting squishy here. So we'll do 1 and 4/30. This is not simplest form. So you can divide all even numbers by 2. And so if we take it down here, 1 4/30, and then divide by 2 halves, just the fraction part, leave the whole number alone. 4 divided by 2 is 2, and 30 divided by 2 is 15. And that works. Okay, so let's try the old way, just for funsies on this one. So 3 times 2 is 6 plus 1 is 7, 7/3. 5 times 1 is 5 plus 1 is 6, 6/5. Now we have to have a common denominator, so let's make 15ths. And if 5 is my scale factor, then 5 times 7 is 35. And if 3 is the scale factor, then it's minus 18. So if you have 35 minus 18, let's just take away 20. So 25, 15, and then put a couple back on. That's how you can do larger subtraction, and you end up with 15 going into 17 one whole time with 2 15ths. So as you can see, it doesn't really matter how you solve these. You can still do the both methods. You could do all 3. You can do one of each. It's really up to you. Okay. For this one, you can do just straight subtraction. 5 minus 2 is 3. Now I've done that, and I need to worry about this later. 6/7 minus 2/3, and then leave the 3 alone. Get the 21sts. This is like just kind of separate. Don't let that bother you. We're going to put it back together later. 3 is the scale factor, and so 3 times 6 is 18. And then 7 is my scale factor, so 7 times 2 is 14. And then when you subtract, there's a difference of 4. And you just put that back. That's what this is for. It just means I'm going to put it back. And as you can see, each method has different benefits. Okay, so this is the brand new way, this is the super old way, and then this is like a middle way. Each method has its own benefits. The number line to show that your answer to G is reasonable. So for G, we're looking at 5 6/7 minus 2 2/3. So if I was to say, I don't even have to go that low. Let's just do 2, 3, 4, 5, and 6. And I'm above 5 when I start, almost all the way. 6/7 is almost all the way. I can take away 2 whole ones. 1, 2. That's reasonable. And then 2/3 of 1. So if this was broken into 2/3, and I have to take away, here's a third and here's a third, I would land a little bit over 3. What's my answer? It's a little bit over 3. So this makes sense. Yes, it makes sense. Okay, so you're just trying to show that this is a reasonable answer, and it is. So moving on. George says that to subtract fractions with different denominators, you always have to multiply the denominators to find the common unit. For example, 8 times 6 is 48. Poor George, he's going to be doing a lot of math. Show George how he could have chosen a denominator smaller than 48 and solved the problem. So I always say line up your denominators and skip count by starting with the larger one, looking for multiples of the smaller one while you go. So 8 times 2 is 16. Again, you're just skip counting. Times 3 is 24. And then 6 times 12, it's like, that looks familiar. 12. 18, oh yeah. And then when you get to 24, you don't have to keep counting. You have to pay attention to what you're counting with and to, and when you find something in common, you just stop there. That's the lowest common denominator. And so basically, that's how you get it. Now, let's take our original problem, 3/8 minus 1/6, and create 24ths. Oh, yeah. Sorry. If I knew how to edit, I would help right now. So you take your 8, I've got to multiply to get 24ths. So I need a scale factor, and it's not going to be 6. So how do I get from 8 to 24? You get there by doing 8 times 3. So 3/3 is my scale factor. 8 times 3 is 24. Therefore, 3 times 3 is 9. How do you get from 6 to 24? Okay, this is times 1, times 2, times 3, times 4. 4/4 is your scale factor. 6 times 4 is 24. 1 times 4 is 4. 9 minus 4 is 5. And then you have your answer in simplest form in one step. If you had done this, you would have 10/48, which is not simplest form. And then you would have to divide by 2 in order to get 5/24. So can you do it this way? Yes, you can. But this is not the simplest way. This is the simplest way. So this is what we're going for. That's right. Simplify, always. Start with the LCD. Woohoo! All right, that's Miss Costello. She says hi. Mei Ling has 1 1/4 liter of orange juice. She drinks 1/3 liter. Woo, she must have been thirsty. How much orange juice does she have left? Extension, we'll do that later. So Mei Ling is starting with 1 1/4 liter. She drinks, that's a subtraction problem, 1/3 liter. And we have to have common denominators, but you have options here. So let's try this the old way. 4 times 1 is 4 plus 1 is 5. I've got my whole amount minus 1/3. I need a common denominator. Let's get 12ths. How do I get there? 3 is my scale factor for this one. It turns into 15. How do I get there for thirds? It's times 4. So 15 minus 4 is 11/12. And that's the liter that's left over. Okay, now, what if her brother drinks twice as much as Mei Ling? So if you take your 1 1/4, if he drinks it after, okay, sorry. You got to be careful with these questions. Sometimes I'm like, I don't know. Would we start with that? No, this one we're going to take our 11/12 liter that's left. And this is the key word there. If he then, after this is left, drinks twice as much as Mei Ling. So twice as much is going to be 2/3 because 1/3 plus 1/3 makes 2/3, and they already have a common denominator, so you don't have to figure that out. Next, I'm going to move my L for liter. Let's just remember that. I can leave 11/12 alone and change thirds to 12ths because 12 is a multiple of 3. And so my scale factor would be 4/4, and I would get 8/12, and then I would do my subtraction and get 3/12, which I can then simplify. Holy moly, they keep you going. 3/12 is not the simplest form. Both numbers can be divided by 3 to give you 1/4 liter left, and that's the extension. And we're almost to the last one. I better hurry up. Harlan used 3.5 kilograms of sand to make a large hourglass. To make a smaller hourglass, he only used 1 3/7 kilogram of sand. How much more sand did it take to make the large one? Then, comparison term, the smaller one. Take your total, 3.5 minus 1 3/7 kilograms for everything. Always check the units. We can do the whole number subtraction first if you want, and do 3 minus 1 is 2. Now leave that alone and worry about the subtraction part. Minus 3/7. Sorry, bumble. There we go. Now I need 14ths. change everything. Sorry, you can't see that either. Scale factor for this one is times 7. Scale factor for this one is times 2. That's where you get the 6. 2 times 3 is 6. Do the subtraction and get 1/14 left over. And then just stick that 2 right back on there. And this is kilograms for the large. I sure hope these are helpful. Click subscribe if you think they're helpful, and if you don't, click subscribe and come back. Maybe the next one will be more helpful. I hope you guys have a great day. See you soon.